Welcome to this training video for the elements in 3D in Witness 14. This tutorial is looking at the basic mapping of the basic elements in Witness to 3D settings. So here we have a model which has an assortment of some of the basic elements from Witness. It has a part, a buffer, a machine, a conveyor, and a labor operator. Let's just hit the 3D button and let's just see what we get as the layout for that. So here we have a layout. We can see that the conveyor is up in the air to a degree, starts off on the floor and then feeds up into an elevated position. We have an operator standing in the idle labor queue, and we have a machine that is idle and waiting for parts. There are no parts actually in the machine being processed. As we run the model, we can see the parts begin to arrive. The operator moves to the machine when he's working at the machine, and moves to the conveyor when the conveyor breaks down in order to repair the conveyor. Now we can observe the 2 and 3D in the walk mode of Witness, so which makes the movement of the parts and the labor more explicit. And we can see now the operator moving to and from the machine and the conveyor to and from the idle position where he goes when he has nothing to do. So in essence, a simple layout and a simple 3D setup. So let's stop the model running for a minute and go and explore how that is set up. So I'm going to close the 3D window and let's just set this back to the beginning time and let's look at how the part is mapped to 3D. This is the part style display. If we go to update graphic from the right mouse menu, we can see there's a 3D button on that dialog. If I hit that 3D button, we get a preview of how that part is going to appear in the view. And here we see it's going to appear as the default mapping from the picture gallery, and we'll have a look at the mapping in the picture gallery a little bit later. But that's going to use the default mapping from the picture gallery, which is linked to this default cube in yellow in 3D, and the size of that cube in 3D is 0.4 by 0.2 by 0.4, so it's half a cube really. It's not as high as it is deep and long. If we wanted to change that mapping, then we could select either not to represent it in 3D at all, or we could use the basic 3D representation. That's just a representation which would map any part to the default part, so in essence we get exactly the same geometry here. Or we can have a totally free choice and we can select user defined mapping. That would let us select any other item in the list here to be our part. Now there is a syntax in this list, dg-pt-, that indicates that that's the default geometry that is suitable for a part, dg-pt- something. But it doesn't stop you using any other geometry in the list. So dg-ic test rig, for example, here, really designed to be an operation or a machining point, but equally well could be a little cage moving along as a part along a conveyor, and you could link a part into that. But I'm going to cancel out of that for the time being. One of the other things that's quite important is that we can, on the part style, scale using the size attributes. Let's do that. Let's scale using the size attributes for this particular part, update the 3D mapping, and just do the quick 3D again. This time I'll use the menu option. What we're going to see now is that instead of the parts in 3D being the size that they were when we linked to them of 0.4 by 0.4 by 0.2, they will now be 1 by 1 by 1, which is the default size in Witness. In fact, they're so big that they don't really quite fit in the machine there. Let's exacerbate the problem and go into the parts dialog, and let's go into actions on create, and let's type in height equals 2. So now for every part that is created, and we can just carry on running the model, every part that's created now will be twice that height, and that will be represented because we're styling to the part attributes, because we're scaling to the part attributes. We will now get every part that's created being twice the height in 3D. So that changes the size of the part. All three of the size attributes, length, width and height, will do that, and you can change any at will during the model, and that will be represented at the next operation that the part moves to. Equally well, in the part dialog, in the 3D settings, we can change the material. Now, if we say use define mapping and we use the same part, we can apply a different color or an image to this part. So if I want these parts to be red, for example, I just select basic red from the materials list, update, and quick 3D, and my parts will all turn red in the display. Let's change the parts back to be a little bit smaller so we can look at the other things in the in the view. So we'll turn off scale using size attributes. That then will revert to the 3D object size that we have linked to in the 3D dialog. If I update that, then we'll see that every part that appears will be the same size in 2D and will still be red, but will be the smaller size of 0.4 by 0.4 by 0.2 in the 3D window here. Now, similar to the part, if we right click on the main machine icon here and go to update graphic, then we have a 3D button that takes us through to the mapping that we're using for the machine, and we have a similar set of options here for a machine. You will have the additional option to use it as a carpet, in which case a 2D orthogonal view from the air would be drawn actually at floor level, just illustrating where the machine would stand, but it would be flattened right down onto floor level if we use it as a carpet. Let's pick a blue machine instead. So we'll OK that option, update it, re-quick 3D the view, and you'll see we have our blue machine there in place. Now let's just run the model for a second or two, and we can see the parts there. Let's just quicken up the walk speed a little bit here, moving into the machine and then moving onto the conveyor representation. Now that's a basic machine mapping. Only one of the machine icons can link to the 3D view, and it is the first one in the icon list that it gets to that has a defined mapping to the view. What we do when we have two icons here, for example, one is the status icon for the machine. If we go into that and we pick 3D, then we set that to be no 3D representation. Otherwise it might pick that one up if it was first in the list for the 3D representation that we're looking for. If none of the icons for a machine have a 3D representation, in other words, if you said all the icons are displayed to be no 3D representation, or indeed you have no icons displayed for the machine at all, then instead of linking an icon to where the part will be positioned, the part Q position is taken as the position for where the parts will be shown in the 3D view. Now that's useful if you've brought in a whole CAD backdrop where machines and conveyors and whatever are already in the view, and you don't want to create an additional icon, but you'd like to layer positions on top of that display or inside that display. You can do that just with part Q positions. If we right click on the graphic for this, if there is no icon display, this 3D setting takes the next precedence, and we have just a queuing position here. We have no visible geometry at all. It will just define where the parts will appear. It needs to be linked to a basic queuing geometry such as this. Now it's exactly the same for the buffer queue position as well. So if we go into there and look at the 3D setting, we can see it's just GG-PQ-buffer. Buffers can have geometries and whatever, but quite frequently they're just the queuing position alone. Parts will just appear aligned with that queuing position in 2D. Let's look at the conveyor layout. Now the conveyor layout here, this uses a path display. Incidentally, paths can be used for 5 different witness elements. It can be used for conveyors, it can be used for path elements, it can be used for tracks from tracks and vehicles, it can be used for buffers, buffer displays. You can have buffers going around corner with a path display such as this, and you can also do power and free sections using path displays. So 5 different path type displays in Witness. All of them are treated in the same way when it comes to 3D. All of them are drawn in various ways that are taught in the Learning Witness books, but if we look at the path toolbar, we can go to the information for the selected path, and that shows us a change of height. So as well as the layout in the XY plane here, we also have a change of height, and that will get reflected through into the 3D view as well, which is why we get part of the conveyor being above floor level in this particular instance. If we go into the display for the path, we can make it different widths and different heights. And if we make, say, the width much smaller here, and we update that display, that is what we will get when we do a quick 3D of this. The whole conveyor layout will be that much smaller, and the parts now are jutting over the edges of that layout. But you set what you want to be the widths of the conveyor purely from the right update graphic, the display dialog for the path. Similarly, now in 3D we can go through here. Now the width and the height here, width and the depth here will have absolutely no effect on the path, but we can change the mapping, and we might look to do that in a second or two. But we can certainly change the height of the conveyor. So if we want it to be really thin, we could set it to be just 0.1 meter. And what I'll also do is I will again select here a user defined mapping, and I will select a different look and feel for this conveyor. So we could select any of these different looks and feels we've got, including we could have an invisible conveyor, use the basic path display, or we could use a section here that has a little roller kind of image on top. So if we wanted it to look more like a roller conveyor, that might be a good option in this case. Let's try that one. We update the view. Let's actually go back in, make it a little bit wider again. And now we can do our 3D display, and you can see that we have a roller texture applied along the length of that conveyor. I'm going to use the 5 key here to take us to an overhead view of the whole facility. We can see the shadow there as well, giving an indication of the different height of the conveyor, and we can see, if I'll just set it running, we can see the different movements around the conveyor. Let me turn the walk motion off so we get more of the conveyor movements in this case, except when the conveyor of course is broken down, and that's when we see the person move to the conveyor to effect the repair. Now the next thing I'd like to show you in this model is how you change the style of the operator. Now unlike the part, you can't on the idle queue do a right click and update graphic, because that actually takes you to the display for the idle queue of the operator. That does have a 3D representation, but that's going to be one of those blank queuing spaces, the same as we had for the buffer and for the part queue at the machine when we weren't displaying the icons. The way to get to the operator style or the labor style here is to go to the full display bar and then select Draw and Style from the first two boxes before selecting the third button and going into the display style for the particular 3D item, the 3D labor item here. We hit the 3D button again. This shows us the person that we are going to select as the labor item here. Now of course we can select other things again. We have the options of a no 3D representation or the user-defined mapping again. So the person could be a complete bed and x-ray machine moving around doing the various things that we want it to do. Or let's pick another of the people. Let's pick a lady in a suit. So let's just say that's what we would like in this view. We hit the draw button for the style and we tick that that's what we wanted to do for the update. Let's hit Quick 3D again, and lo and behold, in our 3D view we have a lady now in a suit who is the person who is going to be our operator for that machine. So it's very simple to change the geometry and the style. You just have to remember that different way of accessing the labor style by using the full display toolbar. I promised to show you how the default mappings are set up in the picture gallery. If we go to view picture gallery, up opens all the icons that we can use in the model, and each of these can have a default 3D shape that can link wherever you use these icons. If we just simply right click on one of the icons, we can select the 3D properties, and in a similar way to we had the mapping options before, we have the same options. We can always choose to have no 3D representation, the basic 3D representation for the type of shape that it's representing, or the user-defined mapping. So if we want it to be a different basic machine for the basic machine icon that we want, if we wanted to say, for example, just use a lobby chair for each of those machines, we could select that in the picture gallery, and then if in the main display here, we're in our 3D icon for the machine, we use mapping from the picture gallery, then it automatically picks up that it will use that lobby chair for that particular machining option. So when we do the quick 3D mapping, we get the different default appearing, and we get a lovely chair used for our machine. Now we're going to move on and look at a different model. So I'm going to the sample models from the start page, and I'm opening Dropline. Dropline is a power and free conveyor model that includes power and free sections, power and free stations, carriers, and network elements. Carriers and power and free sections are quite similar in many ways to tracks and vehicles, in that carriers move along the sections, picking up things and depositing them at different places. So when it comes to 3D, when we define a carrier 3D geometry, we need to define where the parts will appear in relation to the 3D geometry. Now we have a display here for our carrier. If we look at that, that's just an icon drawn. So what we need to do, we need to draw the style again in the same way as we did for labour. And we need to go to the 3D representation, and we can see the carrier geometry that we've picked, and we can pick any other carrier geometry that we wish to pick. But what is important is that you realize that there is a queuing position here defined relative to that carrier, which we'll be looking at in another tutorial about how to set the different part queuing positions in relation to some of the geometries. But if we're happy with that carrier geometry, we are happy with that. If we go to the graphic for the track, which is a path display, again this is a power and free section. If we go to the 3D representation of that, again just as in the conveyors, we have a cross section that will be extruded to the right shape, can go up and down, etc. This particular geometry is the one from the picture gallery again. If we go to defined mapping, there is a way when you're setting the queuing position to say that the queuing and the position of the parts will be below the cross section. For conveyors you would usually want it above, but for power and free where it's carriers maybe hanging from a bar, you might want them to be below, and you have full freedom to set that. So that's set in exactly the same way, just selecting a basic cross-section geometry option, and when we quick 3D this view, this is what we end up getting. We end up getting a power and free conveyor suspended from the ceiling here, and we'll set it running in a little while. We've got other things in this view are the extruded walls and the extruded columns, but we're not particularly interested in those right at the moment. Here's some car bodies arriving into the model, and we see them moving along the power and free section, being held by the carrier geometries which are being defined for the carriers. So again, the layout of the sections here is purely a path display in Witness, and you have all that same freedom to set different heights, changes in height. When things are suspended below a section like this, if there is an incline section, the parts will hang vertically, whereas if they're on top of a section like on a conveyor, then they will be inclined with the incline, as you would naturally expect. Let's have a look at the one of the car geometries here. Let's take the one in the middle here. Let's go to the update graphic. Let's just reinforce how we do parts. If we want the basic defined body or mapping of the car body, and this window can be made bigger, by the way, and you can navigate this window exactly the same way as any other 3D window that you create. You can even make it wireframe. Please see the tutorial on how to navigate these windows to know exactly how to do those kind of options. But we could set that to be a different color, for example. Let's set it to be a pink car body, just for fun. So now, having set that, if we do a quick 3D, we will end up with a number of pink car bodies in the view. So let's just get into a good position here with my different flight, set that running again, and set it going a little bit faster as well. And we can see our new pink car bodies going through the process here of this power and free conveyor system. If when you look at the style dialog for an element it doesn't have a 3D button, then that type of element doesn't support 3D at this point in time. A lot of the designer elements that we have do support 3D. If we go back to the startup model, for example, and we look at the different tabs, all the 4 basic elements in the basic tab do, and on the transport tab, all of these different elements, I mean, the Power and Free network itself has no 3D representation, but the sections, stations and carriers within it have a good 3D representation. Vehicles, tracks, paths, all the different types of conveyors that you have in there are all represented in 3D. A couple of other points worth mentioning. On the model Customize Quick 3D tab, we have the ceiling height. This is used in conjunction with the Power and Free conveyors that we've just looked at to set the height that they are above the floor. But you have also the option to set it on a different floor or a different layer, which can be at a different height as well. So this is a universal setting, but the layers settings get saved with the model, and we'll be looking at different layers and different heights of different layers and floors in another tutorial. The other thing I wanted to say is that you can also, if you're using just any icon that you're drawn, you can draw an icon against the backdrop. So you could just draw an icon on the display. That icon will also get represented in 3D. So you can create any backdrop which doesn't even need to be an element in the model. It can be just a drawing item on the display, and when we quick 3D we get that item drawn. Here it's the only thing being drawn, but it can augment any model view by just drawing any additional icons. We'll be looking at that when we do a tutorial that is going to encase a model inside a whole environment at a later in a later tutorial section. So that's the end of this basic tutorial looking at the basic linkage. Look out for some more expert advice in tutorials that are coming up. Thank you.